morning, class. I'm Mr. Calora. You may be looking at me maybe in my class, or you may be in Mrs. Gary's class. We both teach college math together, and we are going to be dividing out some days. I'll do a lesson. Sometimes Mrs. Gary, we're sort of going to divide it by unit. So this is our first actual lesson of a new topic, and it is an introduction to sets, our first standard. There are a couple skills on it that I wrote behind me. If you want to just pause the video right now and just copy these things down. These are sort of the key concepts. We're going to try to keep these videos to a minimum. So I'm going to kind of try to go through this along with your notes, some of the blanks you may have to fill in. The first concept is we're going to talk about representing sets in alternate forms. There's sort of like two ways you can represent a set. One is in set builder notation, and one is by listing the set out. And we sometimes switch between the different forms. And the second thing is asking us, are sets well defined? So if you're given a set, and the questions may ask you, are they well defined or not? And you'll be doing these in your textbook. The third thing asks you, does a given element or a number or something exist within a set that you're looking at? So do the elements exist in the set? And really it's using the set notation that we're going to define if it's an element or not. And one of the other main ideas is the cardinal number of a set. And this isn't really per se in order of the notes, but these are our three main ideas. If you look at the PDF that you guys have, and you'll notice I'll be looking on my laptop right here because I had your student notes in. The warm-up had to do with some of the definition of the number systems. You will have to know those, so you're going to fill those things in or what we had given you. But the first thing you're going to want to know is a definition, and so that's the definition of a set. So this thing we're talking about, sets, is your main blank. It says A, and you're going to fill in a collection of elements is what goes in the blank. This is your first blank in your notes, and it says that it is named by. Your second blank is going to be a capital letter. So your thing says named by, and the blank is capital letters. So we're always going to choose capital letters when we're naming a set. So like I might say set A equals, for example, or whatever it may be. Let's choose a little better of a marker. So the things that are within your set are called your elements. So your second definition say elements or members, and those are items in the set. So they are, your first blank is, it says you're going to put items in the set. And I'll move out of the way in a second. So our elements, again, I didn't write that up here, but your elements or members are the items you're putting in the set. And they're named by lowercase letters. So your items in the set, and those are named by lowercase letters. So an example, if you look at the next slide, your examples there, it says if if the set of seasons is S, then, and you notice right there, that first example we have, S is going to equal, and we're using braces for all of our sets, and you're just going to list out the seasons. So this is one way that we represent a set, is by listing it out. So we may have, like right now, we're ending summer, going into fall, winter, and spring. And I'm doing another brace. So we're going to ask you guys to do that second example. We'll put that answer up for you if you want to try that. And so we're going to go on to our next definition, which again, this first lesson kind of has some definition, a decent amount of definitions in it. And that is this symbol, as you see E, means, and this is an element in the set. That's what that means. It's an element in the set. So the E with the slash means that it's not an element. So this is just a notation thing. You guys are writing this what that means, like in this chapter, there's going to be a lot of language and some symbols that instead of writing is an element in the set, we just write E with the set. However it's labeled. So say for example, on the left of your notes you guys have a blank. In that blank that you're filling in is, if I were saying 3 is an element in set A, I would just say it like this. You're going to fill in 3 with an E, A. This means, again, 3 is an element of A. So if I was saying that 3 is not an element of set A, the second blank in your notes on this page here, you're going to see it's going to look like this. 3, an E with a slash, and A. Lastly, so the next definition you have, one of the other topics is the cardinal number. And this is the amount of elements within the set. So your definition here, that blank you're writing under cardinal number, that's going to be, your blank should say the amount of elements in the set. So, and the way that we write this is you would write something like, in that last set we had S, right? So we had S equals, and this represented all the seasons. So we had summer, we had spring, we had fall, and we had winter. Now, I will say, the way that you approach a set is it's like a collection of elements. So it's like a bag. You think about things inside of a bag. If you shake it up, it doesn't change what's inside of it, even though I've mixed up the order or where things are. So our order of things, notice the last time I think I wrote this set, it was in a different order. It doesn't matter the order of which you write a set in. Now, so the amount of things, though, the cardinal number of this set is just going to be 1, 2, 3, 4. There's 4 elements in here. So if I was writing the cardinal number out with this, it would say, look something like this. N of set S equals 1, 2, 3, 4, 4. So when I see an N with a parentheses and whatever that set is labeled by, it's going to tell me basically how many things are inside the set, and in this case it's 4. There's 2 definitions in there that are filled in already, and that is finite sets and infinite sets. So an infinite set is something that goes on forever, like the set of natural numbers or counting numbers. The number system continues to go, so that's infinite. Finite means that it's something that I can count. It's a set, it's a whole number amount. And so our next slide you have there is, it's about set builder notation. So set builder notation represents a set where the elements all share common characteristics. So we're going to fill in that blank. So your blank you're filling in is common characteristics. And that's sort of how you describe the set. So what I mean by that, if you look underneath, the set they gave you is the set of days in the week is set D. Then, so they defined it for us, and we would then list out the days of the week. So we've got Monday, I'm going to abbreviate it, Tuesday, Wednesday, and Thursday. Friday, Saturday, Sunday. Now, I will say, I say this example is kind of subpar. It's not the best example we could give because it doesn't say they're weekdays. It's saying days in a week. So it means any of the days in a week. So if it had said our weekdays, not counting weekends, so weekdays, it'd be different. And this one was just saying the days of the week is set D, so then D equals all the different days that make up the week. So the next thing we kind of talk about is the idea of if a set is well-defined. Well-defined, as I was saying, has factual or it says non-opinionated items that are elements of the set. So sort of it's a little easier to explain. Something that is not well-defined is anything that's opinion-based. Things that are well-defined are things that you can look up. And again, you just have to sort of ask yourself with this idea of well-defined is it something that I could find is it information-based? Information-based items are what we're looking for. So if you guys look at your example there, it says, is an Academy Award winner. Now, again, don't overthink this. The first example is really just saying, like if I could look up last year's Academy Award winners, is that a list I could find? And it is. There are clear-cut winners, whether it was based on someone thinking about it or not. It was voted on, and there are winners. You could look up the Academy Award winners for every year. So I can make a list or a set. I can make a set of all the Academy Award winners. Anyone that's ever won one, I could do that up to this point. Now the second example is it tall? So our first example A was, yes, it's well defined. And if you always just ask yourself that question, is it opinionated? That will tell you if it's well defined or not. Now the next one says, it's tall. So that is not well defined. So B is going to be not well defined. And the reason is because, again, I may be tall, I'm about 6'2" to a lot of people. However, I coach basketball. A lot of kids that I have on my team, especially for AAU, I have 6'8" kids, 6'9" kids. Kids that are, last year I had a 7-footer on my team. So, those are tall guys to me. Someone that's really, in my head, above 6'6", 6'7" is considered tall. So everyone's opinion of tall may be different. My mom is about 5'2". She may think I'm tall. So that's opinionated, so it's not well defined. All right, so the next definition is the empty set, or the null set we call it. It has no elements. So in your blank there, you're going to put, it says it has, in your blank you're going to put no. It has no elements. And the way that we write that is empty braces, or we write it as the empty set. We write it like this, or we write it as empty braces. So an example of that is going to be if we said the set of people that's in our math class that's also in the NFL. So if anyone that's in our class is also in the NFL, that set that would make it up is going to be the empty set because there is no one that is going to be in that. And again, you use either one of these. You don't use both. All right, so the universal set is the set of all elements, and is what's written on your paper, and you're gonna fill in that are being considered for specified problems. So the way we kind of always explain this is if you were to think about our solar system and the universe, the universal set is like basically everything that is being considered. So the universe has all the different solar systems inside of them. All the stars, all the solar systems, they're all inside of the universe. So it's all of the things that were being considered for a specified problem. What I mean by that is that universal set can change. I could tell you, just consider for right now that U equals 1, 2, 3, 4, 5, 6, 7. So I'm going to just tell you for right now, and then there may be these other sets that are within that. So it's important to understand that we're not saying the universal is every number possible. The universal set will be given. So for a specified problem, the universal set will be given to you. And so they said for the example there, if the counting numbers from 1 to 10 inclusively were being looked at, in that case our U would be, and this wouldn't have stopped at 7, it would go up through 8, 9, 10, and they use the word inclusively, which is something that we also will define. So this is sort of our last topic, and that is switching between set notations. And I know it's been a little bit of a long video. It's a very definition-based today. So when there are two main ways to represent sets. So we can represent sets by a list, listing out the elements, or by what we call set builder notation. So what this set builder notation does, it defines the set and has a certain format. So for all the problems that you do, if you look at the first example we have there, it says A equals, it has a brace, Y, semicolon, Y is a summer month. And what they're doing is they're telling you that the set is made up of elements. This is saying such that all those elements are summer months. It's giving a definition for each element. So then I would say to myself, well, what are the summer months? So from this definition, I could then also list the set. Now this format, you may say, well, how do I know, when to give this format? Well, if they're telling you to use an alternate definition or switching between them, if they give you things in set builder notation, you are supposed to list them. If they give you a list and ask you to define it, you have to define it. So if you're asking, do I have to write it like this? The answer is yes. There's a few hints with that though. You're always going to use it. I'm going to underline everything that will stay the same. A capital letter, it will depend on the problem what you label it. It's going to have an equal sign, a brace, a variable, semicolon, a variable, and then whatever the definition may be, and it will end with a brace. So these things right here will always look the same when you make things in set builder notation. So I can automatically, before I even decide what's in a set, I could say I'm going to make another set, and I'm going to label it capital X equals brace, variable, semicolon, variable, and then whatever I'm going to define it by, and I'm going to end it with a brace. This part will be the same for all the problems that you define in set builder notation. Now the easy part is when they give it to you like this and you have to list it. So if they ask me to list this, then I would say the summer months, and again it's for set A, so I'm going to match it, are going to be, again if I was writing this in alternate notation like the example asks you, I'm going to write it as, we'll say June, July, and August. Those are the months that we're in summer. So they gave it to me in this form, and I wrote it in this form. If you notice, your form number 2 is written out, 1, 2, 3, up to 60. So I'm going to write that in set builder notation. They gave it to me as a list, and I'm going to write it in set builder notation. So in that example, it's going to be B equals brace, variable, semicolon, variable. And now I'm going to define this. So I'm going to say those are the counting numbers from 1 to 60 inclusively. Counting numbers from 1 to 60 inclusively. All right, and you guys are going to try a couple problems in the textbook going between these two forms. So remember, if they give you set builder notation, you list it. If they give you a list, you write it in set builder notation. And again, this problem right here was the answer to that. But that's an example of a list, or any of the other ones in the textbook that you can see. And now, so the next couple examples, we want you guys actually to fill in whether it's well-defined or not. We define that. You guys could do that. This one is asking if it's an element in the given set, so you should be able to do that on the next slide. And then finite or infinite, we will go over that a little more in class, okay? So I hope this helped give you guys a foundation for this lesson, and we'll talk to you about it tomorrow.